Hello, my name is Sohan Govindaraju, and I'm with the YouthSTEM organization, and this is our first lesson of a two-part series on standard deviation. So, our guiding question for today's lesson is, what is standard deviation? Well, standard deviation is a statistical method that is used to explain how spread out individual data points are from the mean or the average of the entire data set. Keeping that in mind, specifically, we're going to focus on the steps to find standard deviation by hand to completely understand what is standard deviation and how do we find it and really apply it for scenarios and cases in the real life. So, if you were to search up on Google standard deviation, you would probably run across this formula here, which frankly looks pretty complex without any understanding. I'm going to bring your attention over to this key chart here where it details the list of variables that you need to know. So here we have the symbol, Greek symbol, lowercase symbol for sigma, which is used to represent the standard deviation. Now we have n here, which represents the size of the population in the formula, as you can see. Xi, or x initial, represents the individual data points. Data points. And here we have mu, which represents the mean or average, mean slash average of the data set. Okay, so it's important to keep this in mind as we go through the lesson today. Keep it, and I would suggest maybe take a screenshot if you would like of this in case you would need to refer to this later. All right. So the step one is to find the mean of the y-coordinate values only using the symbol mu. So the mean, or mu, is the sum of all terms divided by the number of terms. So the sum of all terms, these y terms, is 12 plus 9 plus 8 plus 23. So mu is equal to 12 plus 9 divided by 4. So mu is equal to, this is going to be 21 plus 31 by 4, which is going to be 52 by 4, which is going to be 13. So mu, or the mean, is going to be 13. Let me just highlight that. Great. So we finished step one, which was to find mu. Let's move on to step two then, which is to find the distance from each data point to the mean. So x1 minus mu is what we're going to do first. Remember, x1 or xi is what you may see in other different formulas. That refers to the individual data points here. So what we want to do is subtract each of these data points, subtract them each from the mean, which is 13. So 12 minus 13 is equal to negative 1. 9 minus 13 is negative 4. 8 minus 13 is negative 5. 23 minus 13 is 10. Great. So let's compare this with that. This matchup. This matchup. Negative 5 and negative 5 matchup. 10 and 10 matchup. So what we did here was the initial data points minus the mean, which was shown right here through these steps, and these match up. All right. So the next step is to square this function. Square x1 minus mu whole squared. So all we want to do is square it. What square means is that you're multiplying the number with itself. So put a 2 square. So negative 1 times negative 1 is going to be 1. That matches up. Negative 4 times negative 4 is going to be 16. That works. Negative 5 times negative 5, that's going to be 25. That works. And 10 times 10 is going to be 100. That works. So our objective in step 2 was to find the distance from each data point to the mean, which is represented by x1 minus mu whole squared, and we did that for each data point. Great, let's move on to step 3 then. So step 3 involves finding the sum of all y-coordinate values from figure 1.3 to find the sigma of x1 minus mu whole squared. So this symbol here is also referred to as sigma. However, notice that it's uppercase, which means that this has a separate meaning, which is to find the sum of all terms. So what that means is that we need to effectively add all these values here. 1 plus 16 plus 25 plus 100. That's going to be 17 plus 25 plus 100, which is going to be 142. So the sigma of x1 minus mu whole squared is going to be 142. Great. Let me put a check. We finished step 3. Alright, 2 more steps to go. So now, using this information of the sigma of x1 minus mu whole squared is equal to 142 for our example data set here, we need to figure out what n is. We know this is going to be 142 based on step 3's info. Step 3. The question mark is, what is n? Now, n, as we've referred to up here, is the size of the population. So effectively the number of terms within the population. Let me scroll back down here, step 4. So n is going to be 1, 2, 3, 4. There's 4 terms. So n is just going to be 4. Highlight that. Now we got to put the 4 down here and do some simple division. 142 by 4. 3 goes in here, 12, 2, bring down the 2, 5 goes in there. So 2 remaining, 35 and 2/4, which is going to be 35.5. So the sigma of x1 minus mu whole square divided by n is going to be 35.5. Great. So we finished step 4. Alright, so the final term is to do the square root of the sigma of x1 minus mu whole squared by n. So that's going to be square root. We figured out that that is going to be 35.5. Square root 35.5. Okay, let's go ahead, check that on a calculator here. What is the square root of 35.5? That's going to be 5.9581. It's equal to 5.9581. Rounding that to the nearest hundredth, which is ideally what we like to do for precision, is 5.96. Okay. Now, before we check that on a standard deviation calculator, just to make sure that our math is correct here and everything is correct as far as our procedure, let's take a look at one thing in terms of the formula. Notice this is the formula that we have, and notice that this is a formula that's provided on Google. They look similar, doesn't it? So the 5-step process results into the same exact formula that they have on Google. Great. Let's go ahead and check this on a standard deviation calculator here that provides us our answer. Delete all this and punch in our data set, which was 12, 9, 8, and 23. Make sure you click it as a population, and let's calculate. So as you notice here, The standard deviation is 5.9581 and the rest of that. But when you round it, it's going to be 5.96. 5.9581 rounded is going to be 5.96. They are the same. Great. So this shows that this 5-step method could indeed be used to solve the standard deviation by hand. And that we verified that by using a calculator. Thank you for listening, and please join for part 2 of the series of using the standard deviation. Thank you.